My name is Sharad Sharma. I'm a professor in data science who recently joined last year from fall semester at UNT. I came from Maryland, spent 15 years over there. So I'll be talking about thanks, mostly about the research topics. Towards the end, maybe we could talk about our new initiative, DSII. DSII is Data Science Industry Innovation Center, where we are trying to collaborate with industry on research projects, which will also include participation with students, internships, jobs, and so on. Okay, so let me start with my research first, and then we'll talk about that. So I kind of specialize in modeling and simulation of human behavior for emergency response and decision making, with focus on multi-agent systems, multi-user virtual reality environments, and mobile augmented reality systems. So I do a lot of emergency response stuff. So sometimes it's not practically possible to create a real-time emergency and collect data, right? So if you knew that an emergency is going to occur, you'll rather stop that from happening in the first place. So our idea is that we'll use virtual reality and more like a multi-user virtual reality. Multi-user, you would have thought about all these games that we all play in the multi-user environment, especially the students, right? So you can enter as an avatar and interact with each other and talk with each other. So that's the idea behind it, that all of us can enter the environment at the same time and participate in this emergency response. So we create a lot of emergency evacuation drills, which I'll talk about. So there's a need for preparation for these events also. When these emergencies occur, how to train people in emergency situations. Of course, these days we see all these fire drills. Every building is supposed to have it. But when it's done, we all know that we can grab our phones and leave our belongings, and we have to just go down the staircase and come back after a few minutes. But in virtual reality environment, you can create all these virtual scenarios, what if situations. You can have fire and smoke in the virtual environment. You cannot have that in real environment, by the way, right? So our idea is that the cost and risk to determine the crowd characteristics or human behavioral characteristics is very high. So to overcome this, creating a multi-user virtual reality environment is a better approach. And as long as the environment feels real, the sense of presence is there inside the environment, you feel that you are part of that environment, you're more likely to collect data about human behavior and human response and how people respond in emergency situations, right? So in real world situations, it's difficult to perform these scenarios with human beings having fire and smoke and creating an emergency because of obviously safety risk issues that accompany with it, as well as legal aspects. IRB will not let you have a user study done where you have people's lives at risk. It's not going to happen anywhere, anytime, right? So I'll talk about few of the environments that we have created in multi-user virtual reality environments. This is one of them. This was funded by Army Research Lab at Aberdeen Proving Grounds in Maryland. The idea was that it's a multi-user environment for a megacity, and the emergency could be a result of fire, smoke, gunman threat, or a bomb blast. And you'll have people who will enter this multi-user environment and participate in this collaborative decision-making approach, where people can enter as SWAT teams, soldiers, group of soldiers, fire responders, traffic clearance staff, medics. So all these people enter the environment together at the same time. But because it's a megacity environment, you need to have many more people. So if like 20, 30 people of us, we enter the environment, we still need 400, 500 more people inside the environment to make it lively, right? So we need to have AI agents or NPCs, non-playing characters, right? So AI agents. So we embedded AI agents, and because it was an army project, we kind of used a army nomenclature. So you have like blue agents, green agents, which depict different behaviors for agents. Obviously, those are cosmetic things. You can replace those green agents with any other character, right? So the idea was that user control agents, which are us, we enter the environment you can enter as a police officer, medic, doctor, or a fireman, or as a soldier, or group of soldiers. You can have a individual behavior as well as a group behavior, SWAT team, or individual soldiers. And then you have the AI agents who enter. And AI agents could be hostile agents, non-hostile agents. It could be panic agents. leader following agents. There are different AI behaviors that we have implemented onto it. So before you start the platform, you can choose how many of these AI agents you want, and then you as user control agents can enter the environment as avatars inside the environment. Right? It was a demo to show that you can enter as a client. Client means you can enter as an avatar, and then you can interact with the environment. So the person out here is wearing an Oculus Rift head-mounted display, and you enter as a fireman, as a soldier, or as a civilian, or so on. Right. So the next project was an active shooter response project. We kind of built it for the campus project, all the university campuses. So it was also funded by NSF. There are two grants that are kind of linked with it. So there are two active shooter modules that we created. First module was for civilians, for us to learn based on the civilian mode, and it's based on the Department of Homeland Security protocol. Then it's based on run, hide, and fight. The first option is, of course, if you have a scenario like this, you run away from the situation. If you can't run away, possibly hide. And the last resort, if you are stuck in a room and there's no other option, then there is the fight mode where you pick up any object that is inside the environment and play around with it. So this is the kind of a simulation that we created inside the environment. We recreated a building on campus so that the people who are participating in the study kind of feel much more closer to that environment. This was an environment for security personnel to get trained. So the security personnel module was kind of divided into 4 modules: situational assessment, individual officer intervention, contract officer or team response, and then rescue task force. So those were individual modules to train the security personnel to respond to those emergency situations. So on the top left corner, you would see like there will be a client side. When you enter into a server, you'll have the IP address and all that stuff, which will kind of show about the multi-user domain, the client server implementation. So in this demo, the character is the civilian, and you enter based on a civilian mode, which could be faculty, students, or visitors on campus. And you look at the scenario of how to respond to the active shooter response module. So of course, you can create different what if situations, like if the active shooter is coming from a different exit, what to do, or if you are stuck in a different room, what will happen in that case. And it's not just about one person, you could have it in a team of people where you can have a collaboration of people taking a decision to reach an exit or a safety zone. This is another simulation. This actually we created somewhere around more than 13 years back, probably. So this was also created in a gaming engine called as Unity, where it was basically an airplane evacuation. And we did a lot of user studies based on this module. We created fire and smoke, and this. So you enter as a client, you could see probably the IP address, and because you enter as a client, you can chat also, but we kind of disabled it because you don't want people chatting with each other during this. So the idea was when the simulation or when the evacuation starts, people will start evacuating. Of course, there would be user control agents and NPCs, AI agents also with it. This is subway evacuation. Again, the idea was there are 2 subways connected with a train, and you enter the environment inside the train. So the train is going in a loop between the 2 train stations. You can exit out from either one of the subway stations. And of course, they will have the building where you can evacuate from there. The other environment was the urban evacuation, where you can enter as a helicopter or as a civilian on top of the roof. There will be mechanism for that. Then there was a school bus evacuation. This environment, actually, we took it to the USA Science Festival in Washington, DC. It was there a couple of places. So you have a small kid playing with this school bus evacuation. The idea was that you can interact and literally open up the hatch and open up the door and then evacuate out from the school bus. This is another environment where we have created a mobile augmented reality system. So again, this environment is created in Unity, which is a gaming engine. The good side with Unity is you can create the environment at one place, and you can export it to a lot of different platforms. You can take it to a cave system. You can take it to a head-mounted display system, Oculus, HTC Vive. You can take it to a mobile system. Mobile system, again, you can take it to iOS or Android system. Even on Windows machines, you can create a exe file, run it on Windows application too. So, so the idea was that uh, these mobile applications will help you in evacuating a building. So most of the times when we go inside buildings, we go in a lobby and you have rooms on either side, especially if it's a library, we all get lost in a library place, and all the aisles and all the uh, um, hallways kind of look similar, right? So the idea is that you can use existing features in the building as markers. So usually, like you have a Pokemon game, right? Augmented reality game. You go to a latitude and longitude, and you see a Pokemon over there, right? So the idea is that you need a marker. In that case, a marker is latitude and longitude. But you can, of course, have a static marker. I can use this as a marker to project out something. So what we do is we use existing features in the building, and existing features are kind of room numbers, which nobody can change, or permanent signs, fire extinguisher, exit signs, room numbers or hallway signs, which you can use as markers to extract where you are, right? So in emergencies, GPS fails, Wi-Fi also fails, but this is more about feature extraction. So it's more about extracting things from the environment. So what you need in place is you need to know the floor plan of that building beforehand, right? So the idea is that you can use mobile phone to show you the actual floor plan, and it will show you the path to the exit. The green arrows kind of show you those. This was a small video where the person is actually wearing HoloLens, so his hands are free. If you are holding the cell phone, then your hands are actually holding the cell phone. Out here it's free, and you can use your gestures to tap and interact with the environment and add more layers of information or layers of data on top of it, right? So layers could be, you can add exit location, room numbers. But if you give too much of information at once to the user, it kind of becomes overwhelming. Nobody wants to see too much at the same time, right? So depending upon your needs, you would like to filter out and see what you would like to. So this is the stuff that we created at UNT, where the location is through feature extraction, not through GPS or Wi-Fi. But there's another part of the project which talks about using that app for navigation purposes outside the building. So outside the building, you can use Google Maps to find the nearest buildings, parking lots, and other places. So next, I'll briefly talk about the 5 active grants that kind of linked with. The top 2 ones are kind of linked with the active shooter response project, which I just talked about. And of course, we're trying to get it transferred to UNT. The third project is an iHeart project, which is part of a data science institute, which is a $13 million grant, which is looking into harnessing data and model revolution in polar regions. So out here, we are kind of creating these data annotations and augmented reality features to see the snow data on top of the existing terrain and see a past history or a time series analysis of how things have changed over the period of time. And then we have another project on high performance intelligent data science institute, and also looking into data science core project where the quality of urban life, we are looking into those kind of scenarios. So I briefly talk about this project. This is about enhancing situational awareness for COVID pandemic. So the idea was that you can extract data in real time and visualize it. So the data is extracted in real time from this JSON file, which is the link is given over there. And you have a platform. The first one is immersive. Second one is non-immersive, which you can use on a computer. Third one is you can use it on your mobile device, which is there on my phone also. The idea is the same. The platform is that we use for developing it is in Unity. But because it's in Unity, you can just export it to different platforms. There will be like almost 90% of the stuff done, but you'll have to create some user interfaces for mobile and for immersive and so on. The idea was that you can see the data for different parameters, people hospitalized, people under COVID, negative, positive, and so on, based on 50 states. And you can zoom out each and every state also. Then the same project was kind of used for showing crime data analysis for a state. So in state, you have different counties. So instead of 50 states, you'll have 14, 15 counties within a city. So this is looking into that. I already talked about the active shooter response. And then the polar region grant is looking into annotation and visualization of heterogeneous data and using augmented reality and virtual reality to annotate the data on HoloLens and tablets and so on. And the other project is uh, looking into HoloLens, using HoloLens for building evacuation, as well as creating virtual reality modules for data distributed systems. And towards the end, this one is talking about the data science RISE proposal that we had, where we had deep learning algorithms and high performance computing for cyber threat, as well as human-centric situational awareness for immersive analytics.